All right, so we're going to talk about some fundamentals of tissue packing, small 3D items. Widely used methodology. There are different variations depending on where you are, and we'll cover a couple of them. Cover some of what to do and what is pointless to do. So basically, one of the fundamental things about it is that when you do any kind of loose fill that is sheet material, whether it be newsprint or tissue, you want to end up with something that is identifiable as what it is, which is as a cushioning material. So they're going to tend to be a pillow, or they're going to be a roll. They're going to be something, they're not just going to be that. Because not only is it kind of sloppy, it's hard to see around, it's hard to tell what you're grabbing when you take it out. It's easy for, if there is a little chip or something, for it to get inside, get lost. So though it's tempting to do that, and many people will do that, and there are probably worse things in life than that, that's not what we're doing. Yeah, the most basic thing is probably something that would just be a pillow. And you could do that with a single sheet. You just sort of start from one end, and as you get going, fold it over to where it is, you know, it's not an open-ended, crunkly whatever. This is like pre-cut bubble. Rather than, as with anything, rather than do things piecemeal, one piece at a time, like cutting individual pieces of bubble, you tend to group the objects by size, figure out roughly what you need, and then you will typically take a roll of bubble and get a long blade and basically slice deep into the roll, and you'll come off with a thick pad of bubble that will lay out like this, and then you can cut it into whatever sections you need, and you'll have a nice healthy stack of similar sized bubble. In this case, generally in this kind of application, it's not a painting, it's not paint surface, so you'll put bubble side in, so you'll have a smooth outer surface. In this case, you can do, we're going to do a lid on this pot. We'll do a little pillow, and that's going to rest on there. So the other variation other than pillows are coils. I was trained doing coils. And that, in this case, you draw down however many layers you need. You know, lots of times we would do 3. Just, you know, if you're doing a standard, that's what we would do. In this case, since it's small, I'm just going to do a single. You got a wad and a wrap, and so a single kind of wad and then one wrap, where you end up with something nice and smooth like this. So that obviously also isn't just a bunch of crumpled stuff. And this can be manipulated around to fit. This folds up this way. This folds up this way. It's if you can avoid taping tissue, if there's not a need to tape it, don't. Many people in traditional wrapping, especially amongst museum folk, is they don't want any more pressure-sensitive material than you have to have. So when we used to line 2D wrapping with glassine, you wouldn't tape the glassine. That was in the specs. You'd only tape the plastic, you know, one whole layer away. So in this case, we're wrapping it up this way. Same thing here. We want minimal tape. This is not going to be a package on the truck by itself. This is going inside of something. More tape we have, the more risk there is of that material sticking to something later that it's not supposed to stick to. This just means more yanking on it to unpack it, and it's just wasteful. So, you know, here I've just got a basic wrap, and all I'm going to do here is just do a tab. And this, if I've got pre-labeled, you know, I could write on here. I could even stick a label on here if I wanted to identify what piece this is, because you now cannot tell. One of the disadvantages of this method. And in fact, some people, you can print out, you know, address labels that have the object number on them and description, and have them ready, peel them off, and stick them on here. And basically, there's a simple package going into a cardboard box to be stuffed out with dunnage of your choice. So now that's a simple package. What you come across a lot, and what makes these things fragile is when you have projections or things that may have been broken already, and that's where the whole thing gets kind of dicey. That's where this method, why they used it a lot. There are different kinds of contact materials. There are times when someone's going to want to use tissue against the surface. This is ceramic. It probably really doesn't need it, but sometimes it will. Sometimes people just spec that. Lots of times if they do want a contact tissue, it's going to be a different tissue from this. It's going to be a softer tissue that looks like a lens tissue, kind of translucent. A common type is called abaca tissue, which is made from banana fiber, actually. So in this case, though, a more modern version that's kind of coming into the use is this high-density polyethylene. Super, super thin. This is like a 0.31 mil plastic. It's a pH neutral. The advantage, of course, is that you can see through it. So that we're going to use that in this case. The thing about this is that this is going to get special attention here to protect those projections, and what we're going to do is kind of the opposite of what a lot of other people do. And I'll explain why. So first we're just going to make us a little coil to nest it in. And that'll go around underneath. And see, it has a little place to sit down in there. So there's quite a bit of cushioning already with that there. We're going to do a single coil, single crumpled coil, and we're going to protect one of these projections. Now here's where we get into the sensible and the insane. One thing that a lot of us are trained to do, myself included, are to fill any voids with tissue. So that'll mean stuffing down in the actual opening there. That'll mean stuffing in the handle here. The notion being that's somehow supporting it and doing something, which you can tell by the way I'm saying that, I don't believe it actually does. In fact, if you're stuffing stuff in here, you're putting pressure where it's weakest. Same thing on the inside of here. Any curved object like this, it's strong in compression, but if you go on the inside, then if there is a slight crack you can't see, it will pop open. I don't know if this has ever happened to you, but if you're washing dishes, you know, I've not picked up a glass and broken it in my hands, but I definitely have cleaned out the inside. A little chip that was microscopic, unseeable, pops open, you cut yourself. We don't want to be doing that to objects, especially since something this soft is not going to do anything to support that opening. It's doing absolutely nothing. This is soft. If something hits there, it's going to break it. This is not going to impact it at all. The only reason where you ostensibly might want to have something inside, and this happens, is if this has been previously broken and has cracks. And especially if it's a larger vessel, you can see it's been broken, or you have information that it is very fragile, you may put some material loosely in the bottom, not pushing, loosely in the bottom, so if a fragment falls in, it lands on something soft and it doesn't rattle around in there. So that would be the thing you would do. So in this case we are going to do something, but what are we going to do? Well, we're going to build out from our projections. And I'll go with this one. And not through it, not over it. We're going to go around it. We're going to create a separate donut, basically, that's going to go around it. And what's the point in that? Well, we're making a little bridge over that piece to where when we bring this bubble up, it's going to span here to where if there's pressure, it's being distributed on that donut. It's not touching the object. I'm going to do another one over here for the, and you can double these over. You can do these any number of ways. I'm going to make another donut that goes around here. This is where having the tissue here actually helps you to wrap it up. I might turn that 90. And hold it in place. So one thing you can see right away, and something that if this process is done correctly, you're going to see that this got a lot bigger. So an object is usually going to at least double, and if it's a complex shape, it may triple in size. When we go to wrap it, the same thing I was talking about. We don't want a whole lot of tape. We basically are just looking for a way to tab it into place. So this would be where you take your tape, tab it, label. If it's not labeled on the tape, do a label, and then this gets packed away. You can see how much that grew in size. So here we've covered the basics. We've got our pretty bulletproof little package, and now all we need to do is combine them, associated with their like objects or their other components, preferably in the same box, and stuff it out with some kind of dunnage. As I mentioned, it's like the old traditional one is crumpled newsprint that are made into pillows in a similar way. You could also use foam, especially for heavier objects. You can also use bagged peanuts. I would not ever use loose peanuts. That can all vary, but there's the core part of the process. All right, so we're just going to talk about the next step. Once we've done our initial soft packing, the kind of traditional use of tissue and bubble, then you're going to put it in a box and stuff it out. Typically the box will have either foam on the bottom or multiple layers of bubble. And you're sort of doing the same thing here. Traditionally with newsprint, in that you're making little packages, you crumple and you wrap to where you don't want it to be able to hide something very well. Like if you had a loose piece, you don't want any confusion, so you want to have like little pillows basically. And then you can use this to just stuff out in between the pieces to separate them from the walls. Here this is holding two away from the wall, like that. The good thing about it is that you can bring a big stack of newsprint, and it doesn't take up that much space, obviously, until it's crumpled, and it's very cost effective. The other alternative that I think people like a lot, especially for heavy items, would be to use scraps of foam that'll fit down in there, especially if things are a little heavier. That can be desirable. Whack them up, put little pieces in there. Of course, the thing about this is it tends to be kind of random. It's depending on the scraps you have. Then the other thing, though, is like I mentioned, using foam if something's a little heavy. In theory, that's still a little iffy, especially one of the basic principles is that you don't mix weights within a box. You keep heavy stuff separate from lighter stuff, and there's good reason for that. In that, if this is something that's heavy, you can put all the foam you want to in there. If it gets shoved over this way, it's still going to move. And it's still going to put pressure on this. Even though it's padded, hopefully that's enough. But if it's something very lightweight and fragile, that could be an issue. So just foam may not be enough. Things you can do is, how we do saddle mounts for some kinds of packing. You can always do kind of a sideways saddle mount. Basically, cut roughly to the depth of the box. And you make these little legs that go to the side, and so that's going to keep that from being able to go this way.